Okay guys, so here we are looking for the magnitude of the impulse that the plate gives to the bullet. So we must find initial momentum. It is given as PA, mass velocity sine of 30, correct? So we put in the numbers, 2, 350s, sine 30s, correct? And that gives us 3.5 as the initial. And then for final momentum, we must do this right here, right? This is equal to, let's put in the numbers that we have before. It's 320 because this is the one after. And we go in the negative direction because that's just when it bounces off. So that gives us 3.2 I. Then to find the impulse, correct, we must do negative 3.2 is 3.5. The inertia, right? 6.7 newtons. So answer is 6.7 newtons. Yes. Okay guys, so here we are looking for what is the speed of the block just after the bullet emerges. So we must use conservation of momentum. Conservation of momentum. We do M1, U1, M2, 2, M1, V1 velocity, M2, V2, right? Okay, so we plug in the numbers, right? We have 10 kilogram bullet, so, and we have that one is a block at rest. Okay, so since it is 50% of the speed, we do 0.01 times 300 because it's moving at 300 meters per second. 300 plus the 0 because we don't have the 0. Then same thing on this side. This one's times 150 because it's 50% of the original speed for the second one, right? And then we do times 1. This is the V2, right? So we're looking for the speed of the block after the bullet emerges, which is V2, and that gives us 1.5 meters per second once you put that in. Okay guys, so for this question, we are looking for if the two vehicles block together, what is their combined velocity immediately after the collision. So we are given the mass, right, of the two cars. Two cars mass we have here. And we have the velocity, correct? Correct. So we put it in the equation. The equation is here given. Correct? So we do put in sorry guys, the V, and then we are giving this right here guys, and then put that in the calculator, we get 6.7 So our answer is 6.9 meters per second. Alrighty guys, so now we have to find what is the instantaneous velocity of the grid when the time is 10 seconds. So we must do this. We must use the equation of acceleration, force over mass, negative 10, because it's the seconds over 100. So velocity, do that times 5, because this is the negative 10 out there, and then this is the 5, plus negative 10, 100, times 10 minus 5, times the half. That then gives us 0.5 plus negative 0.25, which is negative 0.75 meters per second, which then turned into centimeters is negative 75 centimeters seconds. That is our answer. Okay guys, so today we do this question right here. We are looking for what is the speed of the V on the other block. So we must do this. Find the first velocity and we're finding the second velocity. But we are given the block of the mass 3.6 on a frictionless surface with a speed of 9.3. So that is the 9.3, and the second, right? That's the mass one, 3.6. Second one is 0, because we don't have the second one. But we do the mass of the second one, which is gonna be represented as m. When at the 3.6 block, we close with the speed of the final velocity of 2.7 meters per second. We're looking for the speed of the other one when this happens, when they collide. So, as shown before, we do V1, it's M1 minus M2, right? And V1 plus 2 M2 V2 is going to be over M1 plus M2. And then same thing around with the V2, just there's going to be, I'll just write it out. 2 M1 V1 and 2 minus M1, right? 2. And then that's going to be over M plus M2. So now we put it all in. 2.7 negative, because if it's going left, 96 minus M, 9.3 was the velocity given, 3.6 plus M. So the mass of the other one is 6.54. Which is also as 6.6 meters per second. That's the answer. Okay guys, so I do this. We're finding the magnitude of the impulse of the block. Right, so we do inertia, the B, we do M plus M, right? The max minus 0, which gives us eventually A over K, M plus M, right? So we put it in basically. We turn in centimeters into meters. We're doing 8.9, and then last like this, and obviously the grams gets changed to, right, plus 4. This gives us 6.67 kilogram. So my answer was 6.7, but I got it wrong.